Hello students, in this session, we will talk about R programming and a very crucial topic which is mainly catering to GGplot2 package. Now, we have to understand that in this unit, we will be discussing how to use the GGplot2 package to visualize data. What is grammar of graphics? What is a factor? That we have discussed in the previous lectures many times. What is aesthetics, plotting with layers, overriding aesthetics, mapping versus setting, line chart, bar chart, and so on. I hope you all remember line chart, bar chart that we discussed in the previous sections. Apart from that, we will also talk about how to add themes and how to have scatter plots and trend lines. So mainly, this topic is all about GGplot2 package. So let's understand data visualization with R and GGplot2. So as we know that GGplot2 package in our programming language is also termed as grammar of graphics. It is a free, open source and easy to use visualization package which is widely used in R. It is the most powerful visualization package written by Hadley Wickham. Now students, if you remember that we can develop our own packages and we can submit that to R and they can come into the library of R. So in the same way, this package has been written by Hadley Wickham. Layers. So mainly it includes several layers on which it is governed. The layers are as follows. Building blocks of layers with the grammar of graphics, where you have the building blocks. Data. The element is the data set itself. Aesthetics. The data is to map onto the aesthetic attributes such as x-axis, y-axis, color, fill, size, labels, alpha, shape, line width, and line type. Geometrics. How are data being displayed using point, line, histogram, bar, box plot? So here we try to understand that how our data will be displayed on the screen. Facets. Facets are basically to display the subset of the data using columns and rows. Statistics, which is basically binning, smoothing, descriptive, and intermediate. We all have seen binning. That what is binning in statistics? Binning is basically when we are setting the range of data and the particular value is lying in a particular range. Smoothing, descriptive, and intermediate. Coordinates, the space between data and display using Cartesian fixed polar limits. So mainly here we are having Cartesian fixed and polar limits. Theme, which is basically non-data link. So these are the 7 layers which are the basics for the data visualization in R with the GGplot package. Let's have the pictorial representation of all the 7 layers. We can see over here that the main component of the grammar of graphics are, we have the data. First, the blue line represents the data. Over the data, we have the aesthetics. Then we have the geometric objects, followed by facets. Above that, statistical transformation, then coordinates, and then theme. So what is data? These are our data sets. What is aesthetics? Aesthetics are axis, plot position, encodings. What is scale? Scale value, represent multiple values. What is geometric objects? Line, bar, and points. What is statistics? There we talk about mean, quartile, confidence intervals. What is facets? Create subplots based on multiple dimensions. Coordinate system, Cartesian and polar. Now, let's talk about data visualization in R and understand that what it is. We all know that data visualization is the technique used to deliver insight in data using visual cues such as graph, charts, maps, and many other things. This is useful as it helps in intuitive and easy understanding of the large quantities of data and thereby make better decisions regarding it. Some of the commonly used packages are graphics, lattice, and GGplot2 that we have discussed. So now we all know data visualization can be done with the help of graphics library, where excellent for fast and basic plots of data are available. Lattice, where more pretty plots and more often useful in practice. And GGplot2, beautiful plots you want to generate when you want to present the results. So ozone, solar, hour, wind, temperature, and month day. So these are the basic 6 attributes for a particular data set. You can say ozone level, solar, then the value of hour, wind, temperature, and month day. So you can see over here that ozone, solar hour, wind, temperature, month, and day. So you can see 5 stands for the month 5, whereas 1, 2, 3, 4, 5, 6 stands for the day. And temperature you can see 67, 72, and so on. So that is how the values are there pertaining to every column. Now we are having a bar plot over here where we are trying to plot a bar graph. Let's see how we can visualize our data in the form of a bar plot. So mainly students, when we talk of bar plots, the numbers which are there are represented in the form of bars. So there are 2 types of bar plots, horizontal and vertical, which represent data points as horizontal or vertical bars of certain lengths proportional to the value of the data items. So you can see over here that horizontal and vertical bars are there proportional to the value of the data item. They are used for continuous and categorical variable plotting. Horace parameter to true and false gives horizontal and vertical bar plots respectively. So we come to a conclusion that in the bar plot function, we are having a Horace parameter which is giving us a bar plot which is, if it is true, it will be a horizontal bar plot, and if it is false, it will be a vertical bar plot. You can see over here that in this code, we have called the function bar plot where air quality is my data set, and I'm calling I'm pulling the column ozone, which means I'm pulling the values 41, 36, 12, 18, Na, and 28. And then I have taken main equals to ozone concentration in air, which is my title. X label is ozone levels, and Horace equals to true. So you can see a horizontal bar plot which is there that you can see on the graph. We can even have a vertical bar plot with the help of the Horace value equal to false. You can see over here that we have ozone concentration in air as the main, X lab is equal to ozone level, col is equal to blue, which means that the color is blue, Horace is false, and then finally we have the particular output on the screen. Let's talk about a histogram. A histogram is like a bar chart as it uses bars of varying height to represent data distribution. In a histogram, values are grouped together into consecutive intervals called bins. In a histogram, continuous values are grouped and displayed in these bins whose size can be varied. So for a histogram, the parameter xlim can be used to specify the interval within which all the values are to be displayed. And another parameter, which is frec, which stands for frequency, when set to true, denotes the frequency of the various values in the histogram. And when set to false, the probability densities are represented on the y-axis such that they are of the histogram adds up to 1. So you can see over here, we can see that histogram for maximum daily temperature, there we are having the data air quality, and in the histogram I am passing air quality temperature. Main is equal to LaGuardia Airport's maximum temperature daily. X lab is equal to temperature Fahrenheit, which is the label on the x-axis. X limit is 50 to 125. Color is yellow, as you can see. Frequency is true. So here is your histogram. You can see there is a particular histogram which has been created, and it is of yellow color because the color was yellow. You can see over here that C is 50 to 125. So there you can see that the range is from 50 to 125. Now, we all know that there is a 5-number summary. What is a 5-number summary? Whenever I want to have an understanding of the data, I want to know what is the lowest value, what is the highest value, what is the median value, the first quartile and the third quartile, and definitely the interquartile range. So basically what I'm doing, I'm trying to introspect the data and I'm trying to understand that what is this data talking about, where it is set in a set of values, what is the minimum value, what is the highest value, what is the median value, and so on and so forth. So basically, when I want to generate such kind of 5-number summary, I need to have a box plot which depicts information like the minimum and maximum data points, the median value, the first and third quartile and interquartile range. Box plots are used to give a comprehensive statistical descriptions of the data through a visual cue. So let's have a look on the box plot now with an example. Box plot for average wind speed. We can see over here data. Within the data, we pass air quality database. Box plot, air quality, and we pull wind. Wind is my column. Definitely the title is main, average wind speed at LaGuardia Airport. X label is miles per hour. Y label is wind. Color is equal to orange. Border equals to brown. Horizontal equals to true. And notch equals to true. Now you can see this box plot. For the data, this is the box plot which is plotted for the wind speed. You can see over here that the wind speed is on the y-axis and the time is on the x-axis. You can see over here this box plot is having complete information of the wind speed, where if we talk about the data, we will see that wind speed was 67, 72, 74, 62, 56 and 66. The wind speed was 7.48, 12.6, 11.5, 14.3 and 14.9. So there, if we see that the wind speed has been plotted and it has been displayed with the help of the box plot, we come to know that the minimum value is lowest, highest value is little near to the median value, and then we can see that the data is around the median value, which means the data is compact and it is around median, which means there are less outliers, which means that wind speed is almost same for all the times. So that is how we try to understand. Had this box plot been on a very long scale, which means lowest value is high, at very low level, highest is very high, which means wind speed becomes very high at a point of time and it becomes very low at a point of time, which means there is a lot of variation in the wind speed. But here we can see that the wind speed is very near to the median and it is almost constant for all the days. So that is how we try to understand the parameter wind speed with the help of one visual clue, which is box plot. Now let's plot multiple box plots which can also be generated at once through some code. So here you can see I am creating multiple box plots where each is representing an air quality parameter. So you can see over here that I have called the function box plot where I'm passing air quality as my file, and within the air quality I have passed all the rows and columns from 0 to 4, which means all the columns are being selected. And here the title is equated to box plots for air quality parameter. So you can see over here that we have the 4 parameters and all the 4 parameters are there which are having box plots. So you can see over here that the wind speed is constant. It is almost same and it is quite less. So with the help of the box plot, I can understand that in the attribute wind speed, there is less variation. But in the attribute solar hour, there is huge variation. You can see the size of box plot is quite huge, which means the solar light from day to night, it changes. Likewise, temperature, you can see. And so like that, we can compare that which attribute is constant, which is varying. And that is how we try to understand. Suppose I want to find out the carbon footprints in environment. So there I want to find out that which particular parameter is constant throughout the day, which parameter is having huge variation. And when I want to find out the carbon footprints or I want to detect the temperature, it is about 200 to 250 parameters which are taken into consideration. And then we come to a conclusion that tomorrow the temperature would be this, or maybe after in the night this will be the precipitation and this will be the temperature. So basically understanding the data is the toughest task, and to understand the data we need to have good understanding on the visual cues. With the help of visual cues I can always do that.